I will talk about today, soon here. Yeah. In any case, I'm Daniel. I'm working as a technical director of professional services for Curity. I've been there for about 9 years, and I'm working with our customers, trying to implement Curity in the best way, but also like talking about standards and API security, trying to teach the best practices around it. Also been doing the Oauth workshops with Nordic APIs for the many years now. But today, I'm going to talk about this clicker. It's not working yet. Here we go. Today I'm going to talk about verifiable credentials, if I can get the slide running. There we go. Verifiable credentials and how we can create a more create a new way of authenticating that has a higher level of privacy, that keeps more the data in the hands of the users, and we can enable the decentralized identity. This clicker does not like me. There we go. So let's set the scene. We have a user here that wants to enter a bar. This bar has a policy that you're not allowed to go in unless you're 18. So this person looks quite young, so they ask him to, can you give us an ID? Right, and he does, and shows it to him. But when showing this ID, he doesn't really say, I'm over 18. He's giving away his full name, personal number, and also just the fact that I'm allowed to drive, because it was a driver's license that I just showed to the bar clerk here, right? But all I really want to say is, I'm over 18, and here's the proof. So we're giving away a lot of information here that is not necessarily needed for this operation. I just want to prove I'm over 18. Right? And we have the same problem on the internet, or at websites in general, right? We have this bar website that has a login, and they have the same policy. You need to be a user, and you need to be over 18 to get in here. And as any good website, they use an OpenID provider to help with the login process, right? To decentralize the login material and help with the standardized process. And this OpenID provider, in turn, uses an external authentication provider. This could be any type of authentication method, like login with Apple, login with Google, or a national ID, or any type of authentication method that can provide the data needed for a website. So this authentication provider collects data around the user. So authenticating the user, figure out the full name and the birth date of this current user, and passes it back to the OpenID provider, which in turn also pushes it back to the website. So both the website now and the OpenID provider and the authentication provider now knows my full name, my birth date, and any other type of data that's given during authentication. But all I really wanted to prove was I'm over 18. So why do I need to spread this all of this data out in the wild just to prove that? And the problem becomes a bit worse because this authentication provider is also possible to share among different websites. So if I'm using a login with Apple, I'm not going to accuse them about anything, but if they're connected to a bunch of different websites, they're going to have the trace of me logging into these different websites. They're going to know that when I logged in, it's going to know how I logged in, and it's going to know being able to like keeping trace of my habits. Right? I log into the same website every morning. I log into one at night, and during lunchtime I go to Fedora. All that information is possible to find in the logs because every time I log in, I'm making callouts to these different authentication providers. This is not an accusation of any sort. It's just that the possibility is there. The trace is there. In Sweden, we use Swedish bank ID for everything, which means there's a trace of my daily habits everywhere. So this is a problem that Verifiable Credentials is trying to solve. It's one of the things it tries to solve. So Verifiable Credentials is a family of specs created over a collaboration of different standardization organizations. So OpenID Foundation, W3C, and Decentralized Identity Foundation, they made a joint effort to try to build something that we can use in many different places to allow the user to be more control of your data, how it's used and when it's used. So the protocols are based on these facts. So a server, authentication provider, can issue a credential that is usable as is. So a credential is issued to a user, and we can present it to anyone that say, and that entity can then verify this credential and say, this is true, and we have an authority saying that the data in here is correct. This credential is stored in a user wallet on a user device or a website or anything, but a user's wallet. The user is in control. And every time I'm using something from this wallet, I get to decide what information to share. So if we look back at the same type of use case here. So we have this bar website that wants me to prove that I'm over 18 to be able to log in. So first, I need to collect that proof somehow. So now I go directly to the authentication provider and say, give me a proof that I'm over 18. So the provider will authenticate me and make sure that you actually are over 18. Give this information to the OpenID provider that then can issue a credential based on it. So same flow as before, but the difference is this happens once. So the authentication provider gets this information once and then issues a credential for the user to use. And it's stored in a user wallet. That could be portable or located on your phone, probably. Now, I can go to the bar website again. I can present this verifiable credential to the bar and say, here's proof that I'm over 18. Here's a credential that was issued by the government saying I'm over 18. No other information than that. No name, no personal number, no birth date. Just, I'm over 18. Here's proof. The bar website can verify this information locally. So instead of making callouts to make sure that this credential is valid because provider A says so, the proof is in the token or in the credential. And based on information it found, if it thinks that it's okay to trust this specific credential, it can let the user in. So an important part here is, of course, trust. It's always up to the verifier, in this case, the bar website, to see what types of credentials can I actually trust. Like a credential for saying how old I am or about my identity should probably be issued by, let's say, a government or something like that. I should probably not trust I'm over 18 issued by McDonald's, right? So we can collect all of these different types of credentials, but the verifier that actually consumes these gets to decide who to trust. But the user gets to decide what to share, which is really the power here. The wallets in this situation. Of course, we directly go to Apple Wallet, Google Wallet, Samsung Wallet. But a wallet here is a standardized entity. So anyone can implement a wallet according to the standard. This means that you don't have to pick one wallet and keep at it. We can have an airline wallet. We can have retail wallets. We don't have to make sure that everything fits into the Apple world. If Apple decides they want to join the race, then of course we can store some of the credentials in Apple Wallet, but my gym membership probably fits better in another one. So I get to decide what wallet is best. So they're not trying to make a platform war. Will probably be a little bit of it, but in the end, I'm pretty sure that we will have a situation where we have multiple wallets and not just one that won the war. But the point of this is that it makes the user being in control of this data. So I have my credentials in my wallet. Every time I use it, I get to decide what to share. If I lose my wallet, I have to start the process again because, well, it's gone and we can't really get it back. So I'm in control of where that data is. So just a summary. Only the user and the website will interact when using a verifiable credential to authenticate a user. An issued credential is cryptography hardware. It's bound to wallet, and it's only usable from that wallet. So we can't really export from one wallet to another and move things around. The fact that it's only usable by a single wallet means that we can get to trust what wallet to trust, and we cannot move around these credentials. They're bound to a specific device and a specific user. And as I said, it's standardized by the OpenID Foundation together with the other working groups. But the specs are called OpenID for VCs. They're not done. Many of them are in draft state, but we're closing in. And one thing that's driving it currently is the upcoming EU regulations. Right? Not going to say a date because I don't remember, but EU regulations that are coming will mandate each country to have a wallet. And these standards that I'm talking about today are going to be the foundation of those wallets that are going to be regulated. Just some small other use cases. Of course, it's usable for other things than just proving that I'm 18. So like a verified email. We've all went to a website and registered a new user, and you enter your email address, and then you get an email, and you have to like prove that I own my email. So instead of that, Google, since I'm a Gmail user, can issue a credential saying Daniel is holding his email address. Almost got some spam there. But issue it in a credential and allow me to present that when I'm registering a new user. So I don't have to even type my email address. I give the data I need and then give the credential that proves that I own this email address. So we can get away from the step where I have to always prove the ownership. Might be a small use case, but might make it a lot easier to use as well. But let's say boarding cards. When I am out flying and you buy something in the tax-free shop, you always have to show that you have a valid ticket to shop in the tax-free shop. So I need to present my ticket, which says my name and my destination and whatnot. But I only want to show them that I have a valid plane ticket, and the destination I'm going to allows me to shop tax-free. So this could be put into a verified credential as well. College diplomas is, well, a kind of perfect use case, right? The university issues my diploma and says, here, store it in your wallet. And when I go apply for a job, I can just show them my my verified credential instead of photoing it and sending it via post mail, right? So verified credentials is near future, I would say. So we're almost there in the spec makings, but in Curity identity server we can already use it. We can start experimenting with it, and since we're in the API business in the sense that we're issuing tokens for APIs to consume, we can take out the information that we get from verifiable credentials and put into access tokens, making it easier for services to only rely on the information they get from the tokens and only get the data that the user selected to disclose with those APIs. If you want to read more about verifiable credentials and other interesting stuff in the security space, we do put out a lot of information on our blog, and we have an extensive resource article collection. So please have a look if you're interested. But other than that, thank you for listening, and come get me at the booth if you want to ask some more.